Okay, so we use a lot of story problems for this. Suppose 30 flower beetles are left undisturbed in a warehouse bin. The beetle population doubles each week. The function is 30 times 2 raised to x. So they're giving us the function here. That function they call f of x. Given the population after x weeks, how many beetles will be there after 56 days? Okay, so if we look at 56 days, first thing we need to know is how many weeks that is. So as we go through, we're just going to take 56 days divided by, there are 7 days. Okay. So you find out 8 weeks here. Okay, because x is in weeks. So we're going to take 30 times 2 raised to 8. So we're going to multiply 2 times 2 8 times. Okay, now there's tricks to do this if you do it in your head. If you're using a calculator, obviously, yeah, you're going to do 2 raised to 8. If not, if you think about it as 2 times 2 is 4, that's 2 of them. 4 more makes 2 more, which gives you 4 times 4 to be 16. Okay, so that's taking 2, 4. So we're going to take 16 times 16, which make 4 twos times 4 twos, which is 8 twos. So you get 36, 6, and 9. Leave a spot. You get 6 and 1. So you get 6 and 256 times 30. So all I did was I was just taking 2 times 2 times 2 8 times, but I just broke it down into things I know: 4 and 4, 16, 16. So as we simplify this down, I'm going to take now the 30 times the 256. So let's make some room here. Times 30. Again, you can think about this as just being all zeros. Leave it blank. 3 times 6. You get your 18, 15, 16, 6, 7. So it gives you 7680. So 7,680 beetles will be there after 8 weeks. Okay, so initial population of 20 rabbits triples every half year. The function is given to you as after every half year period. How many rabbits will be there after 3 years? So remember, change the years to half years. Okay, so we've kind of talked about how to graph these. We'll go in a little more practice here. Again, I'm going to look at the XY table. And really, from what we've talked about so far, you really should just kind of start with -2, -1. Oops, not -0, 0, 1, and 2. Okay, that's really probably how I would work through this. Just start off with that. And what I'm going to do is I'm just going to plug in these values. So -2 going in for x, it would be 2 to the -2nd, which would be 1/4 times 3, which gives us 3/4. -1 in for the x gives us 2 to the -1st, which is 1/2 times 3, which is 3/2. Okay, so all I'm doing is working that out. -2nd, 1 over 2 to the 2nd, which becomes 1/4. Okay, so remembering rules of exponents. 2 to 0 is 1 times 3 is 3. 1 in for x gives you 2 to the 1st, which is 2 times 3 is 6. And then 2 squared is 4 times 3 is 12. Hey, you won't be able to plot all those, but at least it'll give you some coordinates to go by. 0, you're up 3. 1, you're up 6. 2, you're going to be up here at 12. Okay, but -1, you're up at 1.5, and -2, you're at 3/4, and we keep going that way. Now, it pretty much flatlines. You won't ever go negative, because as we've talked about this, is that even negative numbers produce a negative exponent, which becomes a fraction. It does not make the number negative. So you will never cross this line going downward. Okay, it's just going to go flat across it, not actually equaling 0, just getting smaller and smaller. Okay, so try got it number 3, part A, and got it number 3, part B. I'll give you some points here in a second that you should have if you follow kind of the same repetition that I did. Okay, so that's it for this lesson, and there's your answers for this particular problem for these keys. So check your answers to that, and I'll definitely cover this a little bit tomorrow in class.